The closest to an immortal being is the gene, the unit of information that encodes life. The old maxim about how life achieves this miracle is survival of the fittest. Charles Darwin's theory of evolution, introduced in 1859 in his magnum opus, The Origin of Species, introduced this concept in its fifth edition in 1869. Darwin's work made it unclear why species would seek to cooperate and look after one another when it was not in their survival interest. Unfortunately, this idea led to the erroneous conclusion that the most successful people are the fittest and should not look after less fit people. Late 19th and early 20th century ideologies twisted Darwin's ideas to promote eugenics. Neo-Darwinism, which centered evolution not around species but individual genes, carried over the concept of survival of the fittest but applied to individual genes. Biologist and noted atheist Richard Dawkins made this concept famous with his book, The Selfish Gene. Thus, genes that encode for altruism are selfish in that they attempt to help copies of themselves within other members of the same species, or even other species, to better survive. This mechanism is entirely blind and purposeless. Thus, human traits that we cherish, such as love and compassion, can be boiled down to genes we share that we selfishly want to propagate. Research is now leading scientists, however, to debunk this idea. Firstly, the gene is not selfish, but rather evolved to cooperate with other genes, not only in its own organism, but those of other species. A clear example is the microbiome. Multicellular organisms have a raft of bacteria and other single-celled organisms living inside them and on them without which they would likely die. As one paper's authors put it, a mouse that has no microbiome, a germ-free mouse, develops an abnormal gut, a crippled immune system, and other abnormalities. This is important because it means that the genes of an individual species are dependent on the genes of other species to survive. There are no genetically independent species. Hence, genes have to look out for more than just themselves. Just as survival of the fittest fails for individual members of a species, so it fails for genes. Cooperation is essential to survival. That's why genome sequencing has failed to produce as much revolution in medicine as was promised. Although many diseases are at least partially inherited, gene-centered interpretations of what happens in the body are successful only in rare monogenetic cases. Thus, the reductionist approach to biology that the selfish gene represents fails to grasp the complexity of physiology, ecosystem, or biome. Another related failure of late 20th century biology is the idea that genes are not only selfish, but obey blind processes and have no purpose in what they evolve to do. Science is now discovering life is better explained teleologically, meaning that it has a purpose, that is, adapt to change to continue to exist. Anti-Teleological philosophy, based on the work of 17th century philosopher Baruch Spinoza, one of the fathers of naturalism, along with David Hume, thoroughly infected the teaching of biology in the late 20th century starting in the 1930s. Numerous papers argue that we should remove all teleological language from biology and physiology classes, or at least explain that it is purely metaphorical. Philosopher John Canfield, in 1964 for example, argued that functional statements like "the heart beats in order to circulate blood" and "a function of the liver is to secrete bile" were construed as teleological, indicating purpose, when they are merely function, indicating what these organs do, not what they are for. Attempts to reduce biology to mere physics and chemistry, devoid of purpose, were largely successful in convincing people that life is anti-teleological. Yet, this was not a natural consequence of scientific research, but a concerted effort by big-name scientists, especially quantum physicists, who achieved fame from their discoveries. Danish physicist Niels Bohr was one of the fathers of quantum physics who developed one of the early models of the atom. He was also deeply interested in philosophy, particularly Kant and German idealism. Bohr's approach to biology mirrored his approach to quantum physics in that he wanted to unify mechanism and teleology in a kind of wave-particle duality, where life could at once be mechanistic, but also purposeful. This teleomechanism, Bohr believed, existed as an empirical reality, not an abstract idea, not just a way of talking about blind processes. One could observe the mechanism of an organism and decipher its purpose. This was a kind of proto-complexity theory, where the sum can be more than its parts and purpose may be an emergent property of life. His contemporaries misunderstood his concept of teleomechanism, however, as implying that there was either no mechanism or no teleology. Those who believed that there was no deterministic mechanism took his analogies with quantum physics too seriously. Based on several letters he exchanged with Bohr on the subject, physicist Ernst Pascual Jordan proposed that life was a kind of amplifier of quantum uncertainty. From the indeterminism at the quantum level, therefore, free will, purpose, and self-determination could all arise. Erwin Schrödinger, meanwhile, went in the opposite direction with Bohr's ideas and turned out to be far more influential. His book, What is Life?, had a major impact on the philosophy of life, and no surprise, his theory was gene-centered, mechanistic, and anti-teleological. Life is simply a set of genes carrying out blind physical processes. Life could be reduced to physics. Purpose is all in our minds. This attitude carried the day. The Selfish Gene, published in 1976, was the culmination of such attempts to cast life as a mere collection of blind processes, to reduce humanity to mere automatons. If anything, however, the Selfish Gene has been more influential in that the arguments it makes for an anti-teleological, selfish gene-centered view of evolution are philosophically weak and fail to explain how genes interact to produce life. By the end of the 20th and the beginning of the 21st century, the taboo on teleology was lifting, and in the past few decades there has been a resurgence of interest in teleological explanations for biological phenomena. This has led to a counter-neo-Darwinism that suggests that life is not a mindless, deadly zero-sum game with itself, but rather a process with a purpose. Could it be that Bohr's philosophy, that purpose is an emergent property of the mechanism of life, an empirical reality as true as wave-particle duality, might now become en vogue? A recent example of understanding how organisms can be purposeful is in the relationship between microscopic dynamics and macroscopic structure. The feedback loop between the two can be expressed in terms of goals, where goals are points of stability. For example, Austin and Marmodoro propose a neo-Aristotelian approach based on the Aristotelian concept of powers. To Aristotle, a power is something that causes a change in something else. This can be a kind of force or some property such as rain making pavement wet. Austin and Marmodoro propose that organisms have structural powers. These powers traverse a causal loop within the organism. These structural powers aim to establish a recursively operating mechanism that perpetuates the organism. An example might be the circulation of blood in the body. The heart has the power to circulate blood, which perpetuates your body by feeding the microscopic dynamics of the cells. This recursive loop exists in conjunction with respiration, oxygenating the circulating blood. All of this exists within a goal, a point of stability where the heart and breathing are properly regulated, and this keeps you alive, which is your body's goal. Philosophically, this is not merely a metaphor, but an assertion that purpose is emergent from the causal loop between your cells and your heart and lungs. This is what purpose is. Your body is the way it is because it has a purpose, to stay alive. The same concept can be extended further to multi-organism collectives, such as your body and your gut biome, you and other human beings, and the evolution of life itself for the past 3.5 billion years. In each case, purpose is at the heart of the many causal loops that occur between the microscopic dynamics of genes, the physics of energy and entropy, and the macroscope structure of living things. The stable points in which a species can exist, where it survives and reproduces the best, are goals because they are successful adaptations that recursively maintain the species. A species has powers to perpetuate itself. Such goal-directedness cannot be reduced to simple, mechanistic and non-teleological terms because the powers are themselves teleological, i.e., powers are real and goal-oriented. Systems, whether biological or cybernetic, can only be described in terms of the purposes they work towards. This means that all living things have purpose, and life itself has purpose on this planet. This opens up the possibility of metaphysical as opposed to physical design. Thus, a designer builds into the universe teleology itself as a principle, and evolution works the design rather than, for example, guiding mutations or other events in order to come to a particular design. Hence, purposefulness is at the heart of the cosmos and life, but carried out through secondary processes. This can also have practical applications. Understanding the purpose of a particular mechanism of the body can help doctors understand how to restore it when it fails. A purely mechanistic interpretation, however, misses the point. Biological processes seek to use their powers to maintain themselves. While we often think of goal-directedness as something that can only come from a human mind, this is not necessarily the case. A much broader understanding of purpose is necessary to understand what life is.